Okey-doke. So the next thing is metric calculations. How does EIGRP determine the best path? Okay. This one. I have this network over here. These are serial links over here, which have limited speed. These are Ethernet, good speed, fixed speed. Serial links, depending on how much you want to pay, you get different speeds. Let's set the speed over here to 1544, which at one given time was nirvana, fabulous speeds. Let's say the speed over here between R4 and R6, this link over here is a 512 link. And this link over here is 128. We're doing different colors, might as well do different colors. All right, there's a single path from R1 to R2, single path from R2 to R3, single path from R3 to R4. It really doesn't matter. But over here, between 4, 5, and 6, I do have redundant paths. So let's take a look at metric calculation and see how a particular path is chosen. If this was RIP between 4, 5, and 6, RIP to determine the best path uses what is known as hop counts. Good? So if I want to go from 4 to, let's say, actually I would take the other way around. Let's do it from 5. Let's say I want to go to 6. RIP does not see the speed at all. It just sees which is the closest in terms of hop count. So if I wanted to get to 6, it would have gotten 6 sent to him from here, from R6 directly, and this would be a hop count of 1. Whereas the same route would have been propagated to R4, and R4 would have sent it to R6, but this guy would have added another hop count to it. So without even considering the speed, which RIP does not have the capability of doing, it would have taken the path to R6. Agreed? Now, how does EIGRP do it? EIGRP has a metric calculation formula which includes the speed of the link brings it into the equation. Having said that, it's not as simple as that. What do I mean by that? We'll take a look. The metric calculation formula that you have for EIGRP, and let me write it down and then we'll do it. It's a long drawn out formula, but the one that you need to care about, forget the rest, is this. Bandwidth minimum, actually 10 to the power of 7. This is my way of saying 10 to the power of 7 divided by bandwidth minimum along the path plus delay, which is an attribute of the interface, sum of all the delays of all the interface it goes through, divided by 10. And I don't know why, but they use 256 as a number to multiply it to get the metric, like a cost. So if you take a look at it, there's 2 parameters that are in this formula. What are the 2 parameters in the formula over here? bandwidth and delay. Every interface that you have on a router has these two parameters set: bandwidth and delay. Bandwidth is the speed of the interface, whereas delay is the latency through that link. They're default values on all these interfaces. Okay? The default bandwidth on a serial interface is 1544. Same thing over here. This is your bandwidth. What's your delay? The delay defaults to 20,000 on a serial link. On Ethernet, it's different. Ethernet depends on what? The type of Ethernet, Ethernet, GigE, fast Ethernet, all right? Type of Ethernet is what it determines the speed based on. The delay is 1000. Everybody okay with this? I don't care about the Ethernet, you know it's a single path. Let's focus on this part over here. What did I tell you the speed of the link was that the service provider gave me? 1544 over here, 512 over here, and 128 over here. On a serial link, how many people over here have worked with a serial link? I don't know if you guys have or not. Never? On a serial link, the speed is done or determined by the service provider based on the amount of money that you pay them. So the service provider will set the clock rate of this link, but it's not done by you, it's done by what? The service provider. That's the clock rate of the link. That's the speed of the link. The line rate. Okay? But although the line rate is set by the service provider, the bandwidth parameter is set to default of 1544. So regardless of the clock rate, the metric calculations are done based on the bandwidth command, which defaults to, on a serial link, to T1, which is 1544. So even though my clock rate over here might have been what? 128, that's the line rate. My metric calculations are going to be done based on this value. You understand that? So the metric calculations are based on this logical parameter, which is associated with any interface, which is set to 1544 on a serial link. Let me show you that. Can you see these values? Absolutely. On any of the interfaces, you can see the values. On R3, for example, let's do it on R4 because R4 has both links. Show interface E0/0. And if you take a look at E0/0, it shows you this. Bandwidth, 10,000 kilobits per second. Delay, 1000. This is on a Ethernet link, but if I do a serial link check, this is your serial link, is up. The bandwidth is 1544 kilobits per second. Delay is 20,000. You understand that? Regardless of what the speed is. For example, over here, what I want to do is I want to set this speed. Although the bandwidth is 1544, the actual speed is determined by this command. This is like your speed command. All right. So on my S11, I'm setting my speed at what? All right, but if I check my, oh yeah, on this iOS they change it. If I set the clock rate locally, okay? But if the clock rate is not set locally, it's set by whom? The SP is not a local parameter, right? So over here, what would the bandwidth be? Although my line rate, my clock rate is set to what? 128. My bandwidth, the default bandwidth is 1544. You get my point? But the bandwidth does not determine the actual rate, the line rate does. The reason I'm stressing that is when you go and set your or look at your metric calculation formula, if you do not go manually on router 5, router 6, or for that matter router 4, and go under the interfaces in real life where you set the bandwidth to match what? The line rate? What's going to happen? He's going to treat this link as 1544. He's going to treat this link as 1544, whereas this is not 1544. You understand where I'm trying to get to? So it's imperative that you set the bandwidth of the interface to match your line rate, to get the right proper parameters. Absolutely does. Absolutely does. Okay? So let's do that over here. If I'm assuming that I have certain type of bandwidth, let's go ahead and set the bandwidth of the interfaces to match. So if I'm saying this is 1544, let's set, and I'm saying this is 512 and this is 128. We need to go ahead and manually set the bandwidth of the links to those speeds. So on our 4, S10, I don't need to worry about it. It's the default, right? Bandwidth is 1544. This is a logical parameter. 11, bandwidth is 512. That's between 4 and 6. On 5, 1/0, bandwidth is 1544. S11 is bandwidth is 128. S6, interface S1/0, bandwidth is 512. Interface 1/1, bandwidth is 128. Good. Now let's determine how does EIGRP do the metric calculation. With this in mind, with the formula in place, okay, let's do the metric calculation between from R4 towards network 5. Network 5 over here is a loop back behind R5. There's also a network 6, and I'm going to use 4 over here to determine these bandwidths. So from 4 to 5, what are the different paths? Do I have multiple paths? From 4 to 5. Yes, I do. What if I configure on one side or not on the other one? My path to him will use one path. The return path will be used by the other guy in a different way. It'll still work. It'll lead to what is known as asymmetrical routing, where my path will be A to B. The return path might be from A to C to D, or C to B to A. Get my point? It'll still work, but it'll be asymmetrical routing. So I have this over here. Let's say I have 6 over here. and I have 4 over here. All right. So these are the 3 networks I have. How do I get from 4 to 5? One is direct, one is from via R6. What's the path? What's the cost path over here? How many bandwidths do I have? I have a loop back over here, which is like 500 gig or something like that. So it's always going to be a good speed, fast speed on a loop back. Ethernet is faster than serial as well. So what is the metric calculation formula going to be from R4 to R5 via R5? R4 to network 5 via R5. Let's take a look at the formula and help me fill that out for you guys. Metric says 10 to the power of 7, which is 7. Bandwidth will not. Bandwidth is a logical parameter. So bandwidth is a logical parameter, so it doesn't actually change the line rate. It just changes the metric calculation. So 10 to the power of 7 means 7 zeros, 2, 3, 4, 5, 6, 7, divided by bandwidth minimum. So R4, 1544 is one of the speeds, the other one is high. Which one is minimum? The 1544. All right? So I don't take all the speeds, I just take the bottleneck. Plus delay sum. What was the delay over here? The default delay on serial interface, 20K. What's the delay on a serial, on a loopback? Loopback is about 5,000. We'll see that real quick. Do show interface loopback 0. The default is delay is 5,000. This is the speed. The bandwidth is a loopback. It's got a very high bandwidth, 800,000 kilobits per second. Is it 800,000? 1, 2, 3. 8 million kilobits per second. So between the loopback and serial, definitely the minimum is the loopback. So bandwidth minimum, you divide 10 to the power of 7, followed by delay sum. Delay, I have 2 delays. What are my 2 delays? One is the serial, one is the loopback. So the number becomes 20 plus 5,000, sum. Okay? Divided by 10, and you take this value and you multiply it by 256. Okay, so let's do the math over here. 10 to the power of 7. If you take your calculator out, and you do the math, we'll do 10 to the power of 7, 1, 2, 3, 4, 5, 6, 7, okay, divided by 1544, you get, oops, this is not right, I did multiply, 1, 2, 3, 4, 5, 6, 7, divided by 1544, should be 6476 or something like that. 6476 dot something, right? Drop the dot. Just not even round up, round down, just whatever number you get, the whole number, you take that. So that is 6476. Plus, this is 25,000 divided by 10, which is 2,500. Take that number and multiply it by 256. So the metric over here is 8976 times 256. Now I'm good at math, but not that good. 8976 times 256, a value of 2297856. Good. That's R4 direct. Now, R4 to R5 via R6, what's that second path? I can also go from here. I want to see what the bandwidth is. So what do I do? Let's put the values over here. The minimum bandwidth will be 512 or 128 or the 8 million kilobits per second. It'll be 128, the minimum, right? Everybody agree? So let's plug them in. So via R6, it'll be 10 to the power of 7 divided by 128. Delay will be more. 20,000 for this first serial, 20,000 for the second serial plus 5. So it'll be 20,000 plus 20,000 plus 5 divided by 10 times 256. So the first thing that I need to do is take 10 to the power of 7 divided by 128. 1, 2, 3, 4, 5, 6, 7 divided by 1, 2, 8. 78125. So this number is 78125 plus 4,500. Why 4,500? 20,000, 20,000, 5,000 is 45,000 divided by 10, 4,500. So if I add plus 4,500 to it, you get 82 something. 82,625 multiplied by 256. And that's what your metric calculation is. 21,152,000. Which path should I take? The 2 million or the 21 million? The cost is like the lower the better, right? So that's how EIGRP calculates the metrics. Now the one that I want you guys to take a look at, which is more realistic from the perspective of EIGRP picking the best path. See, from R4 to R5, even RIP would have taken the direct path, which I'm taking over here. Why? Because it would be the hop count. But take a look at the metric calculation from 5 towards 6. So what I want to do is I want to do the same thing. Oops. I want to do it from R5 towards R6 via R6, or let's do R4 as this one and R6 the other one. So two different ways of getting from where? From 5 to 6. Help me out, guys, now with this metric calculation formula. From 5 to 6, 5 to 6 via 4, the first one, the top one. What is the metric calculation formula going to have? How many bandwidths? What bandwidth do I take? I'm going from 5 towards 6 via R4, the first one. Why 512? 1544, 512, and 8 million. So the minimum is 512. Let's put that in over here. 512. What's the speed that the delay? $20,000 plus 20,000. The serial plus serial, and then the 5. So this is the formula. So first things first, I need 10 to the power 7. That's 4567 divided by 512 gets me 19,531. So this number over here is going to be 19,531. Notice the dots, I'm just dropping off. It is tens of microseconds, but the formula, you need to put the whole thing. That's why the divide by 10 comes in. You put the actual microseconds, not the tens of microseconds. So 45,000 divided by 10, which would be 4,500 times that. So I need to do 19,531. 19,531. Oh, come on. 19,531 plus 4,500, which is 24,031 times 256. Did I get it right? So first thing is 19,531 plus 4,500, okay, equals times 19,531 plus 4,500 times 256, which is roughly what? That's the one. 24,031 gets you 6,151,936 approximately. That is correct. The bandwidth is just a metric calculation formula. So the ISP can have any speed. So this is also helping you if you want to manipulate a particular path. You can change it by doing the changing the bandwidth command without affecting the actual speed. Okay. If you want to match it, then you just put it to the same speed as the ISP speed. So it's 6 million from this, the long path. How about the short path, direct path? The direct path from R5 to R6 is via what? This guy, I only have two bandwidth. One is 128 and the other one is 800,000, 8 million kilobits per second. So which one do I take into consideration over here? Help me out. 128. I only have one serial link. All right. So this becomes, we had done this calculation over here, 782. The only thing is 2,500. So this becomes 80,000, 625, I believe. 78125 plus 2,500, 8,625 times 256. You get 20,640,000. So I have 6 million through the long path and 20 million through the short path. Which path should I take? The long path, but the quicker path. So if I go over here on router 5 and I take a look at show IP route, EIGRP includes 6.0.0.0. I'll just do the full. These are all 10s. I don't have 6, I have 66. But the formula that I showed you guys, it's right over here. What is it over here for that 66? 6151,936. This guy over here. Everybody okay with that? You understand that? Would we include 5 loopback? No, because if you look at the path, where are you looking at the path from? You're looking at the path from where? From the router, not even if, let's say, somebody is starting the packet from here and he wants to go over here. When I put the route in, I'm putting the route on router 5. So I'm counting or taking a look at the path from router 5's perspective to this guy. So I'm going to look at the link cost once, link cost once, link cost once. So there's 3 links involved. It's not the interfaces itself. You get my point? So I'm going to take this link, and this link into consideration. But out of the 2 links, in terms of the bandwidth, I'm just going to use the minimum, or out of the 3. But the delay, I'm going to add all 3. So it's going to be, the long path would have been, what, 10 to the power of 7 divided by 512, which is the lowest speed among the 3, plus the delay sum of all 3 interfaces, which is the 45,000, 20,000, 20,000, and 5,000 divided by 10, and then you take it and multiply it. All right, that's where we came up with the 6 mil. Good so far? But what did I tell you also is that although it picked this path, it would still keep this in where? Would it discard the route that R6 sent it directly? Or would it keep it? It would keep it in the topology table as a feasible successor. Can you see that? Well, absolutely can. Let's take a look. I'm on R5, so this is my successor route, by the way. This is your successor route. Show IP EIGRP topology. Let's pick on 6. It shows you the 2 routes. All right. It shows you the 6151936, and it shows you 265,640. Yep. And for voice traffic, it makes a lot more sense. Do you see the 2 paths over here? Good. That's your topology table. Which one? How many successors do I have? 1. It tells you the actual speed of the successor that it picked. That was this guy. So this is your successor. This becomes your feasible successor. Good, everybody? So you saw the topology table as well. You did the metric calculation to figure out the routes. How do they come up with a formula for the metric? Have you driven a car before? Drive the car, dude. Don't forget about how they came up with the car. It's one of those things. They just wanted to take into consideration the latency of a link and also the speed of the link, the minimum speed. On the right side. Well, it depends on the country you're driving in, right? All right, so the metric calculation is done. Where can we see the? It's right here. In the routing table, it will show you that as well. For 66, right here. And that's the one that I remember we did the calculation over here. I don't know if I have it over here. No, this is the worst one. The good one is over here. Good, everybody? So that's the metric calculation one. Route summarization. Let's take a look at route summarization. Any difference? Only the successor route is in the routing table. That is correct. The feasible successor stays in the topology table. In case the successor route goes down, the feasible successor is put into the routing table immediately. Now, route summarization is the next topic. Auto we have done. Now we need to do manual. Just like RIP, you have the ability to summarize multiple common routes under a common summary network. Same, just like RIP. So we put that in. Maybe super, you read my mind, exactly right. So everything else is the same, except for what he mentioned, that you are allowed to do super netting, where you're basically taking multiple routes and summarizing multiple routes, even if they are 4 different major networks, which was not possible with RIP. It is possible over here with EIGRP. All right, so let's take a look at that. Let's do that. Unlike RIP, EIGRP does have the ability to summarize major networks. That's the difference. Other than that, it's pretty much the same. Summarization in EIGRP is done under the interface. So it's a per interface type of thing. So let's take a look at some of these routes. Let's do R5. Show IP route, EIGRP. I want to see what routes I have. I have 106 coming in. From 6, what do I have in 5? I have the 105. I want to change the 105, guys. I want to change the 105 to 205. So interface loopback 101. I want to change that to 205.1.4.1. What does that, guys, make this? Before it was a subnet. Now what is it? It is a major network. Let's advertise it under EIGRP. So 105 I'm going to take off. No network 105. Instead I'll show you a way of advertising all these 4 at the same time. I'll say network 205 1.0.0.0.0.255.255. Will this work? This will advertise all the 205.1 networks, just like a wildcard mask. So basically I'm saying anything that has 205.1 in the first 2 octets, enable EIGRP on it. Whereas RIP, I could not do this. RIP would determine, because there was no wildcard mask, it would advertise 205.1.0 subnet if I had one. So if I go to 6 now, show IP route, EIGRP, I should have the 205 network somewhere. 4 and 5 have come. What happened to the rest? Oh, I call them 206 and 207. IP address 205.1.6.1. IP address 205.1.6.1 and 7.1. Okay, now it should be there. I should just do, there you go. So I have these 4 routes coming in. On router 5, I should see 105 routes coming in. 106, sorry. Right? I want to summarize these 106 routes. How do I do it? Go under the interface, IP summary address, EIGRP 100. This is summarizing 106.1.4.0, exactly the same mechanism that I used yesterday. I'll do the summary on the other interface as well. So I'm setting the summary address both ways. So it's going to get 106.1.4.0/22 via this way and that way. It's going to pick the better metric one, which is this guy from here. So this is chosen, this is not being used. And the other way around, which was not possible in RIP, I can now summarize. I did it on the wrong device. 106 needs to be summarized on R6. Interface S1/0, IP summary address EIGRP 100, 106.1.4.0. Summarize it over here and on here. Okay. So now if I go on to router 5, show IP route EIGRP, and we'll do the include of 106. I'm only receiving one route, right? If I don't do this, it'll show me the actual 106 with the mask of 22. Good. The advantage of RIP. I'll go to 1/0, or sorry, for EIGRP. I do have the ability to do this. This is what it gave me an error yesterday. I have 205.1.4.0. The 4 networks, I'm going to summarize them. This was not possible to do under RIP. So if I go to 6 now, show IP route EIGRP, I will not see 4 routes for 205, I just see the summary. Everybody okay with this? So summarization, the command for that, we did 2 summaries. On R5, I summarized the 205 networks. I need to do it on both interfaces. Now my question to you guys is, what if I only did it on one interface? What's going to happen? Very good, longest match. Now one path is preferred, longest match. See what happens is, let's say I summarized it on this interface. I put the summary command on this interface for the 205 networks. So what am I sending over here? 205.140/22. He's going to send it over here as EIGRP 205.140/22 with the 6 million as its metric. What do I send over here? I didn't summarize on the worst link. I'm going to send the actual path, which is 205.140/24, 205.1, the individual routes. Agreed? What's the cost over here for these? These are all 20 mil. Right? All of them will be in the routing table. I sit on R6 and I ping 205.1.4.1. Which path does it take? Does it go direct using the 20 million path, or does it use the 4 million path? $20 million path? Isn't 6 better than 20? Six is better than 20, but before it looks at the metric, it looks at the longest match. So if I'm trying to ping 2205.1.4.1, I have a longer match for that in this one. So it checks the longer match first and then the metric. So the longer match is this guy. So it'll pick this one and go this way. So you need to make sure you summarize both ways. Let's do that. Let's just so that you guys can see this. What I'll do is I'll take the summary off on one of the interfaces. I'm going to take it off of the S1 interface. So S1, the slower link, 20 mil link, is not summarizing it. So if I do show IP route EIGRP, take a look at the 205 routes. I have 5 of them. The 40/22 is a 6 million, but 205.140/24, 25, 24, 524, 624, 724 are all 20 million paths direct. So if I do a trace route to 205.1.4.1, it is going direct. Why? Because of the longest match. Understood? Everybody okay with that? Do you guys understand that? Now, one question for you guys. This is a slow link. I agree. But take a look at something that's happening over here. Where is all the traffic from 5 going towards, or let's do it the other way around. It doesn't matter which way. Let's say I'm from 6 towards that 205 network. Which path is being used? Everything is getting sent this way. Agreed? Why? This is a better path, right? What is getting sent on this link? Nothing. It's your insurance policy just in case the first one goes down, correct? One of the things that you can do over here is you can say, I want to summarize both ways. But what I also want to do is out of the summary, on this link, I want to leak out one of the specifics or maybe two of the specifics. I'm just going to do one of the specifics over here. What do I mean by leaking it out? When I do a summary, when I put the summary address command, what does it do? What does the summary address do? If I put this as my summary address, which I did, anything that falls under the summary is automatically blocked, or the word is suppressed. Means it's not sent, correct? In EIGRP, another advantage of EIGRP, it allows you the ability to take something out of that if you want. By default, it would block all. So it says block 4.0/24, 5.0/24, 6.0/24, 7.0/24. All of them are blocked, right? If I want, I can leak out one of those routes. Let's say my requirement for the 6th network is just about 100 kilobits per second. So what I can do is for that particular interface, for that particular route, I will leak that out to him and say, hey, listen, for that, just send me to the traffic directly. So I'm at least utilizing this thing for something and alleviating that 100 kilobits per second on the top link. And this capability is called route leaking with summarization. Slow lane, exactly. And it's accomplished by using what is known as a leak map. Okay? So let's do that. So on R5, I do want to do a summary, but on the link between 5 and 6, I'm going to leak one of those routes out. Load balancing would be a better word. Load sharing is when, sorry, you're right. I take that back. This is load sharing, yes. This is load sharing, where I'm sharing the load manually for a particular network on one of the links. So how do I do that? Let's write this down for you guys as well. Leak maps allows you the ability to leak out the specified routes along with the summary address. All right, scenario, I want to leak the 205.1. Let's say 6.0/24 route along with the summary on the S1/1 interface towards R6. How would I do it? Step 1, define the network that you would like to leak out in a ACL or prefix list, whichever one you prefer. Just do an ACL real quick. Let's say 1.1 permit 205.1.6.0 0.0.0.255. Step 2, define a route map and call the ACL. Route dash map, whatever you want to call it. I'll call it LM, just a name. Match IP address. I'm not taking any action. I'm just calling the ACL over there. Good. Third step. Link the leak map or the route map to the summary command under the interface. These are the 3 steps to do a leak map that will leak out a particular route. That is correct. That is correct. I just wanted to do it over here using an ACL. A prefix list would be preferred. So over here under interface S1/1, IP summary dash address, EIGRP 100, 205.1.4.0. Remember the one that I had put in, followed by the keyword leak map, and you call the route map, which is LM. Good. So when I call the route map, see, route map is a very generic capability. It takes on the role that you call it from. For example, later on, not in this class, maybe, yeah, if you've done BGP and BGP, you'll see there's a thing called a suppress map, or there's a thing called a unsuppressed map, which is basically referencing or pointing to a route map. So the route map is a generic tool in iOS that can be used for different things. Here, I'm using it for a different thing. Okay, you guys understand what I did over here? Although this is the way I did it, I can also give you the example if I did it using a prefix list over here. IP prefix list, let's call it LM permit 205.1.6.0/24. That would be the other way to do it. So let's do that as a prefix list over here. So I'm going to go to R5, IP prefix list LM permit 205.1.6.0/24 route dash map LM match IP address prefix LM. Good. And then I would go under my interface, the slow link, and I'll say my summary address. IP summary address, EIGRP 100, 205.1.4.0. This is my summary address, leak map, and LM. It should resync. And now if I go to 6, show IP route EIGRP include 205, you will see that I'm getting the summary route, but it's coming into 46.6, and I'm getting a specific route, the 6th one, the one that I leaked out, to 56.5. Cool? And that's what a leak map is. Fancy thing, but it's a good capability, but the way you implement it is very simple. Questions, guys? Everybody good with this? Okay, good. Give me your email address. I'll send you the bill as well. Just kidding, man. All right, so let's see what we have to do. Hey, what do you know? EIGRP taken care of. I'll show you another thing over here for EIGRP, last thing, and then we'll be done with EIGRP. I'm going to show you the new way of doing EIGRP, which is called the name mode. This is called the classic mode. All right? There are certain advantages depending on how you look at it. A lot of people are used to the old mechanism, the classic mode, and they prefer doing it. But there are certain advantages the way I look at it in the new mode called the named mode. In the name mode, in one place, let's say I was doing EIGRP for IPv6, I was doing it for IPv4, I was doing it with MPLS VPN. In one place, in one under EIGRP instance, I can run all these different things without having to run different instances of EIGRP. So under the name mode, I have the ability to run different EIGRP mechanisms under one umbrella. That's one of the biggest advantages that you have for what? EIGRP name mode. It's a name, not an AS number. So right now, whenever I did EIGRP, I said router EIGRP what? Some number, right? Now I'm not going to give it a number. Instead, I'm going to give it a name, whatever you want to call it. And underneath it, I have the ability to run IPv4, IPv6. If I want to run it for a different, what do you call it, MPLS family, I have the ability to do that. You guys understand that? That's the new way of doing it. Multicast, everything. I mean, it's basically one place, one-stop shop for EIGRP. Not only that, let me ask you another thing. Right now, we did summarization, we did authentication. When we did that, where was my config? I had some config under the router. Config like what? The network statements were over here. If I wanted to do any distribute list, it would be over here. Correct? But where was my, what do you call it? Authentication app. Under the interface. Where was my summarization app? It was under the interface. So I had to do some config within the routing, some config under the interface. Correct? Let's do the same things over here using a name mode. Hello timers. Yeah, any EIGRP configuration that was interface specific would need to be done under the interface. So let's pick a router that we did something with the interface as well. Let's pick on I think R3 had the authentication. Let's check. No. Yeah, see this? I have authentication where? On E00 towards, what do you call it? R2. I'll say no, or actually, let's just do this first. Show run section router EIGRP. So we know what EIGRP we did over there. We have the authentication. Say no EIGRP 100. And I'll default interface E0/0. I'll get rid of my authentication and I'll put it back in with just an IP address. All right, show run interface E0/0, just an interface, no EIGRP. Now I want to do it as a name mode. How would I do it? Router EIGRP. You do a question mark, you have the ability to do it based on the AS number or a word. This is the name mode. Let's call it ABC, just a simple name. Now, once I go inside my ABC, the first thing that I need to do is define my address family I'm running it for and the autonomous system. So I'm going to say address family, IPv4, unicast. Multicast is the future. You can also do multicasting over here. You can do VRFs. Everything is available over here. Just doing unicast for right now. Then I specify my autonomous system. Because the other guy is running 100, I'm going to do the same. Everybody okay with that? So now I'm inside my AS100 configuration. Here is where I would do my network statement to start with. I have those network statements at the top. Let me just copy those. That's why I did this. All right. Notice my neighbor relationship with R4 went up, but not with R2. The reason is it has authentication. So far I've done my network statement already. The stuff that I had to do under router EIGRP is taken care of. I don't have the authentication yet. So how do I do the authentication? I don't need to exit. I just go into my address family interface on E0/0, and now I can put any command that pertains to EIGRP for E0/0. I'm still under the routing mode. So for example, I can say authentication mode MD5, authentication, keychain. What was the name of the keychain? I think it was ABC. If it doesn't work, we'll come back and change it. Give it some time to come up. Oh, no, this was III, I think. Yeah. Yeah, it's III. There you go. My neighbor relationship is up. So how did I do it? Basic stuff right now. Name mode. The right place now. Router, EIGRP 100, address family, IPv4. I'm doing it for IPv4 unicast. Okay. Autonomous system. Is 100. It puts me into a subconfig mode. This is where what my network statements would go. I'll try to remember the ones that we had. I think I had the 10 networks over here. What else did I have? 170 to 16. Good, guys. Everybody okay with this? Still under the address family, I now have the ability to do my AF interface. Address family interface E0/0. And over there, I said what? Authentication, mode MD5, authentication, what do you call it? Keychain. And if you're wondering, is it backward compatible? Absolutely is. You guys already know that. I'm actually establishing a neighbor relationship with 2 and 4, both are running classic. EIGRP stub. Okay, we will do that as well. No worries. Did you not, man, this thing is so small. Specify the key and the key string. I created that already, so I didn't get rid of that. So I'm just still referencing the same keychain name that I have, III. Yeah, I pull the old keychain name, the III. So if I do show run, it's still there. I didn't get rid of it. See this III? That's what I'm referencing. Right? Not only that, if I want to do a summary address over here, I can do summary address over here as well. Because I'm already under EIGRP 100, I'm not under the real interface. I just start with summary address and whatever summary I want to do. Let's say I want to summarize this. Remember, I have a whole bunch of 172 networks. I want to summarize them. I can do that. So even my summary address can be done underneath it. Good, everybody? You understand that? The other advantage that I want to show you guys over here, which config is in topology base. Now, if you wanted to do a distribute list, I'll show you that as well. Let's say I want to do a distribute list over here. Do I have, I did have some. Remember this 172.16 and all those type of routes? Let's say I want to send the odd evens towards R2. So how did I do it? Normally, I would create an ACL or a prefix list. Odd even I would do an ACL, 1, 1. And I would say deny, let's say 172.16.1.0. I'm blocking your odd numbers, right? Create the ACL. If I want to do anything with either distribute list or generally your redistribution, I would do it under what is known as the topology base. And here is where you would specify your distribute dash list 11 out E0/0. Do you get my point? So everything for EIGRP is one place now. I don't need to do a show run interface to figure out what are the EIGRP commands. I do show run router EIGRP and I see everything in one place. Good so far? Now the other advantage that you have, how many types of authentication mechanisms do you guys know about in EIGRP? MD5, right? I told you that earlier on. It does not support clear text. Let's read that statement again. What did I write over here? EIGRP does not support clear text. Did I say it only supports MD5? Nope. It does support SHA in name mode, not in, what do you call it? In the classic mode. All right. How do I do it? In order to do that, if I'm doing it one, I need to have another one that is also name mode. So let's do R4 as name mode. So I'll do do show run section router, no router EIGRP 100, router EIGRP ABC, address family IPv4 unicast, autonomous system 100, network, I'll put these networks in and be done with that. Good. So now I have my neighbor relationships up, but now I do have the ability to go into my interface E0/0, authentication, what question mark, see mode, question mark. What do you guys see over here? HMAC, SHA-256, right? Do I use a keychain? No, I put the password directly over here. Now the authentication is down because the other guy is not doing it. Let's do it over here. AF-interface E0/1, the interface towards R3, authentication mode, HMAC, Cisco 123. Got it? So if I wanted to do authentication with, what do you call it? SHA, I also have the ability to do that. Authentication mode. Was it HMAC SHA-256? I don't remember off the top of my head. Do a question mark generally over here, but let's just check. HMAC SHA-256, yeah. This was on R3 and R4. We said router EIGRP ABC, address dash family IPv4 unicast autonomous system 100 network. I had 34. I had 45. I had 46. I believe I had a 44. You guys got the gist? And then the AF interface, and then the authentication mode, HMAC SHA-256. Fancy stuff, man. That's sure. Name mode as well. So basically everything that you could do over here, I can do over here. It's in one place. Questions? You guys good? Understanding everything? Is router 3 config? Yeah, router 3 and router 4 config, I put it as name mode. I use 100. 100 is just, what do you call it? I think you can change it over here. Okay, MD5 versus SHA security. What is the difference? Much more secure. Good guys, everybody okay with this? ABC is locally significant, yes. Man, the reason I'm slowing down is because I need to read your chats, and my laptop it's got that 4K Ultra HD resolution, and for some reason, man, this WebEx is showing up in like it's like a 0.5 type of thing. So I need to really go down and take a look at what you're reading, what you're writing over here. All right, so good. That took care of EIGRP. You want to take a look at stub. I'll explain that to you guys. What is a EIGRP stub real quick? In order for you to understand EIGRP stub, you need to understand feasibility condition. I think I have a diagram that I can just pull up, and what is it? Is the name mode supported only 15. Yes, 15 and above supports name mode. I don't believe that 12.x supported name mode. It's been a while since I used the 12, but I don't remember it supporting it. Let me pull this. Let me see if I have that. I remember I used to have it somewhere. I'll use that same diagram to explain it to you guys. CCDE, I think, had it. Yeah, there you go. Good memory, man. Okay. You guys, I want your attention for the next 10 to 15 minutes to understand a very important part of EIGRP internals. It's not going to help you configure it better, but understand it a little better. Completely different. EIGRP and OSPF stub are completely different. OSPF is for an area, EIGRP is for a router. Okay, let's take a look at this, understand how EIGRP exchanges its routes. You remember when we did the metric calculation of bandwidth and delay? We would get large numbers. Remember that? We got 6 million somewhere, 2 million somewhere, 20 million other places. Remember that? Now, what I'm doing over here is I'm simulating this network 10.1.1.0, which is behind R2. He's sending that particular route towards A, router A, towards B, towards C. R2's cost to get to 10.1.1.0 is 2 million. That would include the bandwidth and the delay and the whole formula, and R2's cost would have been 2 million. Everybody okay with it so far? Guys, follow along, be interactive over here so I know you're on the same page. They'll go faster then. Now, when R2 sends that 10.1.1.0 to A or to B or to C, it sends his cost to the destination. To whom? To the neighbor. So R2's cost to the neighbor, to this network 10.1.1.0 is 2 million. So he's going to send that cost to A. What A does with it, it keeps that 2 million. And I'll tell you what that VM and the CM is, but it keeps the cost of 2 million. What does it have to do with it? It needs to, that is router 2's cost to 10.1.1. A needs to determine what is his cost to get to R2. And what does he determine over there? His cost to get to A2 from A to R2 is 25. So he says, oh, this guy's cost is what? 2 million. My cost to get to R2 is 25 million. So my total cost is what? 27 million. You understand how I got these? This is what R2 advertised to me. This is what I determined as my cost to 10.1.1.0. How come? Because his cost is 2, my cost to get to him is 25, so my total cost is 27. Agreed? Now some terminology over here. The cost that was advertised by R2 is his cost to him. This has different names depending on the notes or books or documents that you read. Some people call it the advertised distance. Some people call it the reported distance. Some people call it the vector metric. Vector metric. Vector metric, advertised distance, reported distance is what router 2 sent to A. What did A do with that vector metric or advertised distance or reported distance? He added the cost from A to R2. Agreed? Yeah? That over here is called the composite metric. Also known as the feasible distance. Good so far? You guys okay with the A calculations? Now similarly, R2 sent 10110 to whom? B. B took it, the vector metric, the advertised distance, report distance, whatever you want to call it is 2, which is R2's distance. But then B has a cost of 18 million to get to R2. So it puts a composite metric at 20 million, 2 plus 18. C also gets 2 as the reported distance from R2, the vector metric, adds 10, gets 12. Agreed, understood so far. So you understand what that VM and CM is on A, B, and C. Good. Now, A sends those metrics to 1. What does A send to 1? A will send his composite metric. To whom? To R1. Okay? A sends his composite metric to R1, which R1 calls the advertised distance, reported distance, or the vector metric. B will do the same. B will send his composite metric to A, to R1. C will send his composite metric to R1 because that is what? C's cost to the destination. A treats that cost as what? The vector. 27 is the vector over here. B has a vector of 20. C has a vector of 12. Understood? But what does R1 do? This is like your topology table of what? Of R1, because it has 3 different ways of getting to what? The 10.1.1.0 network. A will add the cost over here as 5, make it 32. A will add the cost 15 over here, make it 35. And R1 will add the cost of 5 or 15 or 12 to the advertised distance or the vector metric and make it into what? The composite metric. Good so far? So now, if you take a look at R1's topology table, it's going to have 3 different ways of getting to what? 10110, agree? Right? Which one does it put in the routing table? It will pick the one that has a lowest composite metric. Which is the lowest composite metric? 32, 35, or 24? 24, right? So C becomes the successor. Done? The other 2 that I have over here, what are the other 2? This is your successor. The other 2 are A and B. Stay in the topology table. Good? Now, this is where the word feasible comes in. EIGRP wants to make sure it is a loop-free environment. EIGRP wants to make sure it's a loop-free environment. So what is R1's best cost to get to network 10.1.1.0? The best metric. 24, right? The number is 24. it compares its best metric against the remaining routes in the topology table. Okay, compares what? What is its best metric? 24. What did B send it as his vector metric? What is B's cost to the destination? $20. Everybody understand? Everybody follow along? Is there any chance that by disabling split horizon or having any loop that B is sending my route back to me? No. Why not? Because his cost is 20, my cost is 24. So if R1 has sent his route to B, it would have added something to it. It would have been greater than that. It is better than 24 route. It means there's no chance B's route, B is a loop. Agreed? So that's your feasibility condition. So that means this route is a feasible route. What do I mean by a feasible route? Feasible route means it is a completely loop-free route. 100% loop-free. You guys understand that? It is 100% loop-free. How is it 100% loop-free? My best route is 24, but B's route is 20, which is better than mine. That means I could not have given him my route and he's sending it back to me. Good so far? The reason I'm saying that, let's take a look at A now. Is there a chance that A, whose vector metric is 27, that means his cost is what? 27. He might, I'm not saying he's doing it. Is there a chance that I send him 24 and he send me my route back at 27? Is there a chance? Yes, there is a chance. So that basically means he does not meet the feasibility condition. It is not, I cannot 100% say it's loop free. So I don't meet the feasibility condition and I will take this route out of my topology table. This condition check is called, this condition is called the feasibility condition. What does the feasibility condition say? My neighbor's cost to the destination should be better than my best cost. Let me write that down for you guys. So for a route to remain in the topology table as a feasible successor, it needs to meet the feasibility condition. And what is the feasibility condition? FC. The neighbor's cost to the destination should be better. Better means what? Lower than my successor cost. Let me read this first. That's the VM of the neighbor. Yeah. That's the VM of the neighbor. Correct. Oh, that's a composite of the neighbor, not the VM. See over here? So R1 will compare 24 with 27. Got it? If it doesn't, so what do you have in your topology table now? You'll have one successor, which is C, and you have what? One feasible successor, which is B. Why did A not make it? Because it did not meet the feasibility condition. You understand that? So just because you see this topology over here does not necessarily mean that you have all three paths in your topology table. It still needs to go through the feasibility condition. If one of the routers doesn't make it, it will pull that route out for that particular destination. The feasible is placed. The feasible is placed in the successor is placed in the routing table, and then it calculates. If C drops, what happens? If C drops, I don't need to do any algorithm running. What do? C drops, I have a route in my topology table. I'll pull it immediately and put it into what? My routing table. Good. It does not do anything with this. This one is lost. Very quick convergence. A was lost. When A sent the route to him, he says, thank you very much, I got it. So it does not send him 10. It does not send the same route 10110 again. But at the same time, A is still up. But I'm not, I am sending the keep alives. I'm not sending the routes again. What did router 1 do with A? It discarded this route, so it doesn't have A. So now if C goes down, how many routes do I have in my topology or my routing table? Just one. It does not have A. Why? As soon as this went down, it checked this topology table. It saw there's a valid feasible success over here, put it into the routing table. Done. I'm done. I don't do anything else. Good. Everybody okay with this? Now, the thing is, what if I'm really on the bad side of luck, and not only did I lose this, I also lost B. A is up. What happens now? Recalculate what? I don't have this route. Remember, I discarded the route. If I lose a route and I don't have a feasible successor, EIGRP knows it might have done that feasibility condition and dropped the route. So what it does is, if it loses the route, let's say it lost this route first, this link is down, now I add B, B is gone. What it does, it sends a query on all the existing interfaces. It sends a query over here saying, hey, listen, you know what? Do you happen to have a route for 10110? A responds back, yeah, I do. I told you, what did you do with it? No, it's not stuck in active. It goes into active state, finds from A the route. It goes into active state. Active means it queries. He sends a query, he sends a reply back. It says, okay, thank you very much. I got the route. Now this route becomes the successor, but it didn't pull it out from the topology table. It had to query for it. So where do I send the query? To all the other neighbors except for the ones that got down or I lost them. So I'm sending a query to him. I'm also sending a query to him. He will come back and say, I don't have it. He'll come back, here's 10110. It's still within seconds. It's still better than OSPF or any of the other routing protocols, but it's not as good as dual. Dual is the best because dual, I'm not doing anything. I'm just picking it up from where? I have it ready. I know what is my feasible successor. I just put it in. You get my point, but it's still a little slower than it would have to do with what? With dual. Because with dual, it's in your topology table. I just pull it up and put it in. Good, everybody? I can't read this one. What does it recalculate then? Recalculate where? Richard, say that again. What happens when the link recovers? Is that what you're saying? Oh, when the previous links are restored, yeah, then it recalculates, right? So a link is restored, a new route comes in. So let's say this link was restored. So it comes back in as what? A composite of 32, and this is a composite of 32. So it still remains the best route because if you really look at it, A was a better route than B. A's composite distance was what? 32. B's composite distance was 35. So if B comes up, A remains as the successor and he will become the feasible successor. If it meets the feasibility condition, which it does, because B's cost is 18 and my cost is 32. So if B comes up, what is the thing that happens? He remains as the successor, he becomes a feasible successor. What if C comes up? His cost is 24, recalculates, he says this is a successor now, and then it does the feasibility condition with A, says, oh, you can't do it, boom, gone. You understand that? Clear? Now why did I explain this to you guys? First, I want you guys to understand the feasibility condition. Now, based on this, I want you guys to understand another thing. This router over here, router X, it's getting all its EIGRP updates from where? R1. So if R1 loses an EIGRP route, let's say it had lost that 10.1, would he happen to have it? No. Why? He's getting all the routes from one. He's a dead end router. Right? So what's the purpose of doing a query over here? No purpose, right? Why am I sending a query to RX? He's getting all the routes from me. If I lost it, he's not going to have it. So if I know for a fact that X is a router, that is getting all its routes from where? R1, he is technically a dead end router called a stub. Let stub router, right? So I'm going to make him a stub router. By making him a stub router, router X will tell R1, listen, I'm a stub router. Please don't send me any queries. But I need to configure that. EIGRP does not know that. You know that because you know the topology. So what you need to do is you need to go to that router X and tell him, hey, you're a stub. When you make the router into a stub, that basically tells the upstream router, do not send me any query updates or query packets because I'm not going to have any routes. So it makes it a little bit more efficient. Make sense? So how do I do it? In our case, in our topology over here, if you take a look at it, R1 can be a stub, right? Because it's a dead end to R2. So what I can do on R1, I'll show you before and after over here. On R1, I can say show IP, EIGRP, neighbor, details. R1 is over there, static neighbor, blase, 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 normal stuff, right? I'll go to router 1 and I'll say EIGRP stub, means I'm a dead end device. So it brings it up, down, and then brings it back up. Now if I go over here for R1, it tells you that it is a stub router. All right. So by doing it as a stub router, it's going to suppress any query packets going through it. And it tells you that. That's what a stub router is. So in EIGRP, stub is not a network, it's not an area, it is a router. And what does it mean that you're making a router into a stub router? That basically means I am not going to be receiving any query packets from a neighbor in case the upstream router lost a route, and because of feasibility condition, he does not have any routes in the topology table. So it sends a query to everyone. He's not going to send it to R1. Good, everybody? Does it get to store all the routes from R1 or just have it? No, it has all the routes. So it's not like, again, as I said, it's not like OSPF where stub only gets a some default gateway and all that. It has all the routes. It's just that I'm not going to get any queries. Good, guys? So how do I make it? The theory behind it was big, but how do you make a router into a stub, an EIGRP stub? Just go in there and say EIGRP stub. Manually, yeah. You need to do that. So I'll add that over here to your notes. EIGRP stub. It allows a router to tell its upstream router not to send any query packets to it as it is receiving all its EIGRP routes from him. So how do I do it? Router EIGRP 100 EIGRP stub, just like that. But I needed you to understand the feasibility condition. I needed you guys to understand the query packets so you understand the significance of EIGRP stub. You guys understand EIGRP now? So this is EIGRP to the max. How many participants do you have today? Is it less than 100? Because I would prefer using Zoom. The problem over here is I can barely see your questions, man. I just need to go right next to the thing. What is this? Could you explain application bandwidth percent? Okay. Let me talk to Catherine, because I'm really having a hard time reading it because I need to pull my laptop right next to my eyes. Okay. Let me talk to Katie and then I'll let you know. So keep an eye on the thing. If you guys remember the Zoom ID from yesterday, it's the same ID I'm going to use. The WebEx you guys already have over there. So either we're going to use the WebEx or Zoom. Because I'm having a real hard time reading it. Now the bandwidth percent is something that EIGRP allows us the ability to do. It's something in today's networks doesn't matter, but in the older days when it came out, it used to be an important thing. EIGRP is the only protocol that self-governs itself. Let's say I had router 1 connected to router 2 over a slow link. Let's say it's a 128K link. It's a OneDrive link. Let me explain this. I'll show you that too. So you have router 1 and router 2. Router 1 has a huge database. Let's say it requires its routing table exchange would require, let's say, 500 kilobits per second. Okay. Let's say it was OSPF as a protocol or RIP as a protocol. As soon as they would come up, they would just flood this link with what? The routing update. So until that table would go across, the data traffic would be limited. EIGRP is a protocol. What it does is it automatically self-governs itself. What do I mean by self-governs itself? What it does is it says on a link, I will never take up more than 50% utilization or 50% of the bandwidth. So even though I need 500 kilobits per second, this link is 128 kilobits per second. I'm going to send it in 64 kilobit chunks, allowing at least 64 for the data. The default is 50%. So bandwidth percent that EIGRP will utilize on a link, self-police itself, is 50%. So it's going to send 64, 64, so on and so forth until it finishes. Does that make sense? Can you change that percent from 50% to something else? You can. But the default is 50%. It's again another one of those parameters that you do under the interface. It's an interface specific parameter. So I would do IP, bandwidth percent, EIGRP, AS number, and specify a number. Let's say I don't want it to be I want EIGRP to take a little bit more because I have ample bandwidth, 75. So 75 would be the percent now. So I would take up 75% of the bandwidth for EIGRP at a maximum. All right. Now, what did you guys write? What is the link? Okay. All right, brilliant. So tomorrow, you guys, everybody will do OSPF tomorrow. Don't miss it. It's a lot of good work with a lot of good stuff with OSPF. We'll go into the LSAs. I'll explain how the LSAs work.